This video is about solving systems in two variables using substitution. Alright, so I know this is a bit of an Algebra 1 throwback, but I thought it was important that we talked about it anyway. So when solving a system with substitution, and this kind of works no matter if it's two or three variables anyway, what you want to do is solve one of the equations for one of its variables, substitute the expression you got from step 1 into the other equation, solve for the other variable, and then substitute the value from step 2 into either original equation and solve to find the value of the variable you don't have already. So let me do some demonstrations here. So let's start off with this question. Now I have choices. For the sake of demonstration, I'm going to solve for y on the bottom equation. The reason is I'll have everything nice and positive. So if I say negative 2x plus y equals 7, and then I add 2x to both sides of my equation, I end up with y equals 2x plus 7. It's nice and pretty. I want the y equal. I want to be either y equals or x equals. So far, task achieved. This is step 1. Step 2 is I'm going to take this equation that I've got, and I'm going to put it into the equation I didn't mess with yet, which is the top one. So I'm going to replace where it says y with this stuff. So the top equation says 3x plus, and where it says y, I'm going to replace it with 2x plus 7, and then equals negative 3. And now I'm going to solve it just like I would a normal equation. So 3x plus 2x is 5x. Plus 7 equals negative 3. Okay, I'm going to subtract 7 from both sides of my equation. And I get that 5x equals negative 10. I divide by my coefficient 5, and I find that x equals negative 2. All right, so now I've got x equals a letter. I'm going to take that, and I can plug it into either equation. It doesn't matter which one. I'm going to choose the bottom one, just because I picked the top one before, whatever. So all I'm going to do is my bottom one that I said will be negative 2, and I'm going to replace the x with what we know. And then plus y equals 7. Negative 2 times negative 2 is positive 4, so 4 plus y equals 7. Subtract away the 4. I got y equals 7, 6, 5, 4, 3. To properly format this answer, they should go in alphabetical order as a coordinate. So it would be x, y, so negative 2, comma 3. And there's my solution. Not too bad. So let's do another one. All right, so for this one, I'm going to look at it, and I'm going to think to myself, to me, this time it looks like the top equation is going to be the easier one to work. And I say that because if I add the 3y to both sides, I get x equals, and everything's going to be positive. So let's start that way. There's not a wrong way to start this. It's just there's a more work and less work. The more of these you do, the easier it is for you to see the easiest path. So x minus 3y equals 9. If I add 3y to both sides, I get that x equals 3y plus 9. So you see how last time I started solving for y equals, this time it's x equals. It doesn't really make a difference. So I'm going to take this, and I'm going to plug it into the equation I didn't use yet, which is the bottom one. So my x value is 3y plus 9, and the rest of the equation was plus 4y equals 2. So you can see how I took this and plugged it in where the x was in this equation. I'm just going to combine my like terms. 3y plus 4y is 4, 5, 6, 7y plus 9 equals 2. I'm going to subtract the 9, and we'll get 7y equals negative 7. Divide by my coefficient, 7. and y equals -1. Again, I can choose either equation. Just for fun, I'm going to pick the bottom one again. Hey, why not, right? So here we go. X plus 4, and then my y value was -1. And I'm color coding it just so you can kind of see where I'm putting things. Equals 2, okay? So that means that x minus 4 equals 2. Because 4 times -1, -4, right? I'm going to add 4 to both sides of my equation, and I will get that x equals 6. So my solution would be 6, -1. Not too bad. Let's do one more just for good measure. So this one takes a little bit more thinking, and what I'm looking for is what's the easiest way to get a single variable by itself. In this case, it looks to me like it's the top equation, because if I get rid of the 3x, I'm left with y equals, no dividing. I don't want to divide unless I have to, because dividing means fractions, and fractions means more work that I would like to avoid if at all possible. So we'll do 3x plus y equals 14. We will subtract 3x from both sides. Y equals -3x plus 14. I'm going to take this and plug it into the equation I did not use. The equation I did not use was, let's see, the bottom one. So it will be 2x minus 6. And then what was y is now going to be -3x plus 14 equals -24. Okay, so 2x, -6 times -3 is positive 18x. -6 times 14, I don't know my multiples of 14, so 6 times 14. 6 times 14 is 84, so it'll be a -84 equals -24. I collect my like terms. 18x and 2x will be 20x minus 84 equals -24. Okay, I'm going to add over my 84. And let's see here. 84 minus 24 is going to be 60. Divide by my coefficient of 20. And we get that x equals 3. Easy enough. I'm going to take that and plug it into my top equation. Why not? So 3 times, we said x is 3, plus y equals 14. So 9 plus y equals 14. We will subtract away the 9, and y equals 5. Got my two pieces, put them together, x comma y, 3 comma 5. And there we go. We're just going to follow that same pattern anytime that we want to solve a system in two variables using substitution.